So for video assignment 3, the question was use the Lagrange multipliers to find the maximum and minimum values of f of x and y equals xy subject to the constraint x squared plus y squared equals 25. So I'm going to write that down for you guys. So use Lagrange the maximum and minimum values and minimum values of f of x to y equals xy subject to the constraint x squared plus y squared equals 25. Okay, so that'll be our written out equation. So first, I kind of want to start off with defining the constraint. So I'm going to do formula is g of, pretty much just switching f and g. G meaning my constraint. So x of y is equal to our original equation, x squared plus y squared. And then what I want to do is, because I'm pretty much using this as a constraint, I want to solve for it in a way. So I'm going to move the 25 over by subtracting it, 25, so that I can equal the whole equation to 0. So pretty much from here, the method we're using is the Lagrange multipliers. So you're going to get the, I'll space it out for you guys. F equals lambda of range g, which g, remember, our original equation. And then from here, we want to plug in our formula, which was, again, of f. I'm not sure how to write the symbol, but I kind of write it like that, of f, and then that of x, of f and y equals our original coordinates, except they're flipped now, x of y. That's kind of what I have. So if you go back and you kind of flip it in, because of the, exponents, I'm going to carry it over to the front. In a way, if we were pretty much taking the derivative of it. So it gives you g equals, then same thing, you carry the exponent to the front, and then that subtracts 1, so that's going to be 2x comma 2y. Thus meaning y of x from here is equal to lambda from our original equation up here, and then now we plug in this, which is what we got down here. So lambda of 2x comma 2y. So now from here, all you're doing is just plugging in, or you're pretty much factoring over, and then you're isolating. So factor it over, and then you're isolating. So I want to get y, so that's gonna be y is equal to 2 lambda of x. And what I kind of did was I just factored over, giving you 2 lambda x and then 2 lambda y. All I did was I just isolated the y out, so I brought it out of the equation and then moved it over, giving you that. And the same thing for x. X equals 2 lambda y. Add these so you know they're separate. And then the original equation, x squared plus y squared equals 25. And these are all together. So now pretty much all you want to do from here is solve for x and for y. So what you do is you multiply the two equations together. So I'm going to do x multiplied by y, and then you grab your two equations, which is going to be your x equation, and this is going to be your y equation. So this will be 2 lambda x multiplied by 2 lambda y is equal to 4. And then there's 2 lambdas, so there's 4 lambda squared xy combines. And then pretty much since xy cannot equal 0, at the extrema you have to divide by the x and y. So this moves it over. xy, let me just rewrite the whole thing. So 4 lambda squared xy 0. Well, in a way, not really, because you want to have this over like that. So all you're doing is dividing that out, dividing this out. So that's gonna be 4 lambda squared is equal to 1, because that all cancels out into 1. So pretty much, if you want to solve for that, that would give you pretty much isolating that out. So that is divided by 4, divided by 4. Lambda squared is equal to 1/4. Want to get that out, so lambda is equal to calculation. So radical 1/4 is equal to 1/2. So that simplifies to 1/2 plus minus, because you're square root. So pretty much in the first testing, what I'm going to use is positive 1/2, and then for my second testing to prove the case, I'm going to use negative 1/2. So this will be my plug-in vector. So in the scenario lambda equals 1/2, we're gonna plug that in. So you would get your original y equals x, and then you would have to add the constraint of it, which was pretty much the 2x squared equals 25. And then from here you want to solve it. So you divide by 2, divide by 2. Let me show you the calculation of it. So 25 divided by 2 is 12.5, which 12.5, keep it a fraction for you guys. So this is going to be 25 over 2. Let it focus for a second. 25 over 2 equals to x squared, square root that. So then x squared is pretty much going to be, so this is going to pretty much simplify to radical 25, which is going to equal to 5, and then radical 2 is going to equal to radical 2. That doesn't change. So it's going to be 5 over radical 2 plus minus, because your radical symbol. So the points in this case is going to be 5 over radical 2, 5 over radical 2. That's 1 point. And then your negative signs, because the plus minus would be negative 5 over radical 2, comma, negative 5 over radical 2. So the function value of this would be f equals x of y, which because remember we were solving for this at the beginning. That was what we were dividing by to isolate our lambda over here. So we kind of want to keep that idea. So x of y is equal to our original is 25/2. Now, because our original equation gave us lambda equals plus minus 1/2, we already did this scenario with positive 1/2. Now we gotta redo the whole thing with a scenario of negative 1/2. So in the scenario, lambda equals negative 1/2. I'm gonna do the same. So y is equal to, I'm treating lambda as the x vector, so this would be, now because negative 1/2, it would be negative x for our equation. So same thing again, we're writing our 2x squared equals 25, and then we already know this all simplifies to plus minus 5 over radical 2, so we can skip that whole method, or we can skip that whole calculation and get 5 over radical 2 plus minus. Now, because the whole thing with the negative symbol on the lambda sign doesn't really change anything. Our vectors are still pretty much the same, only because it's squared, so it's going to cancel it out at the end. So it pretty much doesn't change any of our answers. It still gives you the x equals 5 over radical 2, meaning our points only slightly differ in the in this area, giving us 5 over radical 2 comma negative 5 over radical 2. Same thing over here. Because this was our y, now we're going to switch it to the x being negative 5 over radical 2 comma 5 over radical 2. And you might be asking, why did both of these become negative and both of these stay positive, whereas right here only one of these was negative, and then only one of these was negative, rather than both of them be negative and both of them be positive. So this has to go back with our x being a negative, which kind of keeps this, but because we still had that negative from the previous equation that we got over here, we can't really leave it out or throw it out and not do anything with it. So what I did was I pretty much just transferred over to the y over here, kind of flipping our equation as if it was x equals negative y. So it's the same thing. You get the same answers. It doesn't really differ too much from it. So our function would equal to f equals x of y, which is the same thing except it's negative 25/2. So our maximum is the highest point, and because this is positive, this would be our maximum. So our maximum value is equal to 25/2, and then and this happens at this coordinate, which is going to be at 5 over radical 2 comma 5 over radical 2 and negative 5 over radical 2 comma negative 5 over radical 2. So you can see that. And then our minimum value, which is pretty much the lowest value that we can get, is negative 25/2, because you can't go anywhere past that. So minimum value is equal to negative 25/2 at 5 radical 2 comma negative 5 over radical 2, our coordinate point, and negative 5 over radical 2 comma 5 over radical 2. And that's pretty much our answers. So to sum it back up, our original question was use the Lagrange multipliers to find the maximum and the minimum values of f xy equals xy subject. So our maximum value is at 25/2, and then our minimum value is negative 25/2. Thank you.